This is number 5 on the mid-unit test, on the mid-unit review. This question is on multiplicity. So multiplicity comes from lesson 2.10. Here's a video to further explain that. On A, the function shown on the right, so here you have a graph, has 3 x-intercepts. Right here, let me label them for you. There's an x-intercept right here because the graph either touches or intersects the x-axis right here and right here. Okay, 3 x-intercepts. Complete the sentence frames by identifying the multiplicity of each x-intercept and providing your reasoning. So for this first x-intercept, that is -3. So the x-intercept is -3, and what gave me this x-intercept was this factor here, was x plus 3 gave me this x-intercept. But notice that the graph is coming down and then it touches the x-intercept and then it goes back up. It doesn't intersect it. So when this happens, this is a multiplicity of 2 because the graph doesn't change sign. Notice that the y values here are positive. It didn't intersect. If it intersects, that means you're dealing with an odd multiplicity. Okay, so one more time. Since the graph is coming down, it touches the x-axis, and then it goes back up. That's a multiplicity of 2, or an even multiplicity. So x equals -3 has a multiplicity of 2 because you could say something like the signs on the f of x don't change. Okay. However, now look at this one here. So the graph is coming down, and at 0 it touches it, but it keeps coming down. So it intersects it. So right here is a multiplicity of, this is x equals 0. This is a multiplicity of 1. So whenever you see a graph that intersects it completely, that's a multiplicity of 1. Let me look at question number 4 as an example to talk about multiplicity. In this part here, the graph intersects it completely. That means we only have one of the parentheses. There, it's a unique x-intercept. You don't have a duplicate. Also here, the graph just starts from low and then it goes up and it intersects it. That's because we have one unique parenthesis here. And same thing on the other side. They all have a multiplicity of 1. Now on number 5, this is a multiplicity of 1. When they go like this, is a multiplicity of 1 or an odd. Okay. And finally on this one, let me use a different color. The x-intercept is x equals 4, but what gave me that was x minus 4. Notice that it goes through it, just like this one, it goes through it, but it kind of does this extra, has this extra curve. So the multiplicity on something, on a scenario like this, would be 3. Okay, so that is part A on multiplicity. And the last question is 5B. Draw a rough sketch of this polynomial. Okay, so here you think of multiplicity. You also have to use what you know about multiplicity to make the graphs. Okay, so the x-intercepts. From here, the x-intercept is -6. From here, the x-intercept is -2. Uh, from here, the x-intercept is +4. Okay, so it is -6, -2, and 4. So I go over here and I'm gonna just label those things. -6, -2, and 4. So this is where my graph is gonna intersect or touch. Okay, the degree. So the degree, let's see, we have 1 here, 1x there, and 2 here. So that's 2, 3, 4. This is a 4th degree, so it is even. Since it's even, I know that something happens in the middle, and my end behaviors are gonna behave like this. Yes. Okay, and finally the sign of the leading coefficient. So you look at x here, and the leading coefficient here, or next to the x, is 1. Right here, in front of the x, there's a 1. And then here is also 1. Positive. So if you multiply all of these, you still get +1. So the sign of the leading coefficient is going to be positive. So this is correct. The even with the leading coefficient positive, the end behavior is going to look like this. It's going to look like that. But now here comes the multiplicity concept. The x plus 6, this parenthesis here, the x plus 6, that means I'm just going to go through it. It changes from positive to negative. It crosses directly because there's a unique solution. Same thing with this one. With x plus 2, it has to come up and it has to cross it. It has just to go through it as well. However, something on this one, it's different because we have a multiplicity of 2. We have an even. So that would be something like over here, like this little curve where it's going to come down, it's going to touch it, and you see that it's going to shoot back up. Okay, this is a rough sketch and that is fine, but because we could also find out how low this point gets. We could also find out how high this point gets, and we could also find out where does the graph cross the y-axis. Those are other things that we could find out to make it to make this a better picture.